Hi everyone, I'm José Valim, and I'm really glad to announce the Bumblebee project. The Bumblebee project brings a variety of neural network models right into Elixir. We have implemented in pure Elixir models ranging from GPT2 to Stable Diffusion, and we can also download trained parameters for those models directly from Hugging Face. So in order to explain what all this means, I'm going to show how anyone can use the new version of Livebook, Livebook 0.8, to get started with their first neural network in Elixir with only 3 clicks. Are you ready? Let's get started. So what I have here is that I have a new notebook already running. And in order to get started, to run your first neural network in Livebook 0.8, we need to click on a smart cell, and then we say we want a neural network task. And now we evaluate this smart cell, and you can see what it's going to give us is that it not only gives us a machine learning model, but it gives us an input so we can directly interact with it. So for example, the task that we have here by default is using image classification. So what I can do is that I can drag a picture of a toucan. It's my favorite bird. There is even one behind me here. So I can drag and drop it here and run it, and it's going to say, hey, there you go. This is for sure a toucan. And what is really nice that for each task, we have like several models. So this is using ResNet, but I can say, hey, what if we run VIT, right? So if we do that, I can evaluate the cell again. And I can give it another try. And this is going to give me a slightly different output because it's another model, right? But that's the idea. We can try different models with different inputs and evaluate and try to understand which ones makes more sense to us, right? And we not only have image classification, we can do text generation as well, right? So for example, if we want to use GPT-2, for example, the base one, we can say, hey, yesterday I was reading a book and we want to generate some text, and that's going to generate some text for us. And you can see like the first run takes a little bit of time, and that's because we are compiling the model. But if we go and just change the text now and run it again, it's going to be much faster because the model is already compiled, so now we are just doing the prediction, right? And you can go and you can play like with the different parameters that each model support, right? So that's it. That's text generation. You can increase the amount of tokens generated, the maximum tokens, and so on. Other things that we can do text to image using Stable Diffusion and a huge variety of Stable Diffusion models. And unfortunately, this machine I'm recording on, I don't have a GPU, but that's also something that we are working on, making really accessible like remote instances with GPU for you to run your Livebooks on. But it's topic for another day. For now, let's continue with the tasks, right? And we can also do like text classification, right? So if I change the model here and I run it again, now I have another model for text classification. Again, several possibilities, and we can say, hey, what is this doing, right? So this is really neat, and you can see how you can play around with things. But the cool thing about smart cells, so for those who are not familiar with Livebook, Livebook is a computational notebook. And we have this feature called smart cells, which we have been using here. And the thing about smart cells is that at the end of the day, they are just code. They are only about code and nothing more, which means that we can actually go and see this code. So it's not like, oh, hey, here's a neural network and good luck figuring out how it works. All the code that makes all those neural networks here, all those neural networks work, it's right here. We can see it, we can play with it, right? So we can see what we are doing here is that we are loading the model from Hugging Face, then we are loading the tokenizer for text, we need the tokenizer, so we are loading that. And what we do is that we build the serving. This is going to be very important later on, okay? We build the serving, which is basically say, hey, I want a serving for text classification using this model, using this tokenizer. My batch size is going to be 1. The sequence length is 100, so we configure everything. We use the XLA compiler for performance, so it can run on both CPU and GPU, right? And this is pretty much the model definition, right? And what we do next, that we define the form. I want to have a text area, I want to have a form, and I want to have a frame. I want to have a place where I'm going to write the output, right? So what we do is that we get a stream from the form events, and we listen to this stream, and we say, look, every time we receive an event from the form, okay, we are going to render in the frame that we are running, right? So we are going to run the model, and we effectively run the model. So we are using an X serving, and we are passing the serving that we defined here. We are passing the text that we want it to do the text classification on, and then we're going to get predictions, and we build a scored list out of those predictions and render them into the frame. And that's pretty much what we have here, right? And what is really cool is that because we show the code, you can actually go around now and play with it and do whatever you want. Like maybe you want to do something more interesting. Maybe you have some documents that you want to fetch from some API and run text classification on, or do summarization. You can do all those things, right? You can just start building on this code. We can even click this button, right? Like convert to code cell, and it's going to convert the smart cell to code. It actually breaks the model and the form into two distinct cells, so you can evolve in one without changing the other and take it anywhere you want, right? So this is it. Like this is how you can use Bumblebee and Livebook together to get started playing with machine learning, playing with neural networks really, really quickly and build on top of that, right? But this is also not all. In the same way that we can get like this model, right, and run it in Livebook, we can also get this model and embed that into a Phoenix application, right? Or use Broadway to put that as part of a data processing pipeline and start running productions on inputs that you're getting from somewhere, right? So we can do all those things, and that's exactly what I want to show for the second part of this video. All right, so for the second part of this video, we are going to get that text classification neural network and embed that into a Phoenix application, so we can do like sentiment analysis as users are typing in real time. So what I have here is a Phoenix 1.7 app running on my machine, and I just created it, just generated it, and I've only done 2 changes to it, which is, those are the changes described in the Bumblebee project README, which is, I have added Bumblebee and the XLA compiler as dependencies, and I configured NX to use XLA by default for performance. That's it. Everything else is just a stock Phoenix app, right? So let's build this new page. Let's build this new functionality. So I'm going to use Livebook for that, so we can do everything in real time, and we won't have to write JavaScript. We're going to control everything from Phoenix and from Elixir. So I'm going to create a new page live file. And again, in the interest of time, I'm going to copy the layout of this page, okay? So I've defined the module. I said it's a live view. And here is the layout. And this is just layout. There's no logic. There is no Phoenix specific event handlers, just HTML and CSS with Tailwind. So I'm going to save this file, and I'm going to go to the router and say, hey, my home page now is going to be this page live that we just created. Okay, so after doing this change, we can come back to Firefox. I'm going to reload the page, and we can see that we have our new page now with an input for us to do the text classification. I have a spinner that is always running because, again, we just have the elements, nothing is working yet. So let's start adding the functionality to this page, okay? So going back to our page, there are a couple of things that we want to do. So first of all, we want to say, look, every time an input in this form changes, I want to trigger the phx change event, and we're going to call this event predict, okay? Let's also add a debounce to this input. Oops. So let's say 300 milliseconds. So if I start typing, if there's a small break, that's when we start doing the text classification. You can increase this in any way you want. And we also want to align the value of the input in the client with the value on the server. So we are going to say that the value of the input is going to be given by the text variable, okay? Something else that we want to do is that if we do the prediction and we have a result, we want to print the result. So that's another variable that we're going to use to keep track of things. And finally, we are only going to show the spinner if there is a task running. So what we're going to do is that when the user types something and we are going to run the prediction, we will start a task so we don't block the live view, so the user can continue interacting and doing other things in the live view. So we're going to start a task, the task is going to do the prediction and give the result back to us, right? So if we have a task then we show the spinner. If we don't have a task, we don't show the spinner. So that's it. We have one event, and our state's going to be 3 assigns: text, result, and task. Okay? So what we're going to do here, now that we define the state, I'm going to define the mount callback. This is the thing that is called when the page is mounted, when the page is loaded. And it receives parameters that we don't care, it receives sessions that we don't care, and it receives the socket. And we know that the socket is going to need all the data that we defined below, right? Text, which we can start as new. It's going to need a task, which is new, and the result that is new. Okay, so this should allow our page to load again, which it does. But if we interact with the page, it crashes, right? Because we are sending like this predict event that we don't know how to handle. So it crashes and then it's reloaded by Phoenix automatically. So let's do that. Let's implement the event. So we want to define a handle event for the predict event that we define here in the form. It's going to receive some parameters and the socket. And what we're going to do is the following. Look, if in the parameters we have a text and the text is empty, like if the user erases everything from the input, it's kind of like starting over, right? It's like, okay, let's just start over. Let's kind of roll back everything. So I'm going to say, look, there is nothing to reply in this handle event, and we kind of start everything from scratch. But otherwise, if there is an actual text, what we want to do is that we want to start a task. And we could, instead of like going and adding all the prediction logic right here, right now, what I'll do is that I'll just simulate some sleep for now, so we don't worry about the details. So for now, we only focus on the UI and the events. We're going to return like joy, okay? So that's going to return a task. And after we do this, what we want to do is that we are going to, again, return with a socket. The text is going to be the text that we have received. The task is this task. And we want to reset the result, right? Because if we had a previous result, every time we start a new task, we kind of want to ignore the previous result because they're going to show something new. All right, so this is it. I'm going to close this and I'm going to use the formatter to make sure that this code is beautiful. So that's it. That's the code. So we are handling the event by starting a task. And what is going to happen is that the task is going to run asynchronously. And when the task is done, it's going to send an event back to this live view. And this event has this shape, ref result. This is a reference so we can identify the task and the result. And what we want to do is that, because if the user types, right, and then we stop, and then there is a task running and they start typing again, there's going to be another task. So we're only interested in the result if this reference match the reference that we have in our task right now, okay? So if those two things match, what I'm going to do, I'm just going to copy and paste here. I'm going to say, look, the text, we are not going to change it. It's going to be whatever it was. The task is going to be new because it's over, right? The task is done. And the result is going to be the result that we received. That's it. And in case we receive this message and it doesn't match the one in the task, I'm just going to ignore it, right? So I'm going to define, sorry, I should receive the socket here. So I'm going to define like a catch-all. Sometimes we say joking the Pokemon clause that catches everything. And so, you know, if it doesn't match the message, we're just going to return the socket. There's nothing to do. We can safely ignore this message. And this is it. This is all the functionality that we need to make this UI work and tick. Okay, so let's go back here. It was already reloaded. So if I started typing, I stop for a little bit, and then like, this is awesome. It's going to go and do the prediction, which right now is just a static joy string. So we are done. The UI is ready. All right, like the events are ready. All we need to do is to make it work with the machine learning model. All right. So in order to make this work, okay, so this is the code that we want to bring. And in order to make this work, this serving property here that we get is essential. This is a new feature coming in NX that we just released yesterday. So the idea with NX serving is that it kind of encapsulates all of the tasks that you want to do, right? Related to neural network, data processing, whatever you can do with an X, right? Even traditional machine learning algorithms and so on. It encapsulates the whole thing, right? And when it encapsulates the whole thing, you can run a single event against it. But what you can also do is that you can embed that into a separate process and start batching requests. And this is very important because if you're thinking about like neural network models, especially when they're running on the GPU. So for example, imagine they're receiving a bunch of requests to do text classification, right? You don't want to go one by one to the GPU because it's in the name. The GPU is really good for parallelizing things. Right, so what we want to do is that we want to batch. So say, look, I'm going to try to get as many requests for text classification within the default, for example, of 100 milliseconds. I'm going to get as many as I can, right? And then if I get 10, I'm going to predict them immediately. Otherwise, I wait until the timeout and I'm going to pad and predict that, right? So that's the idea here. Okay, the idea is that we can use the serving to batch the requests and do multiple things at once, which is going to be very efficient for the GPU. So what this means, right? So because this is all part of NX, in order to add like the actual prediction to our application, we need to do the following. So first, I'm going to copy and paste this code. And what I'm going to do is that I'm going to go to my application file. And here, this application file, it has a supervision tree which defines a bunch of services, right? So we have a telemetry services, we have a pub subsystem, we have a HTTP connection. If you're talking to the database, our database connection will be here. So what we have here is that like you can think of each Elixir application as having a bunch of services running. And what is really cool is exactly that those services, they are embedded into my app, into a lot of other platforms. If you want to do PubSub, you would have to install a separate system to do the PubSub. Here, everything is part of Elixir. Everything is running within Elixir. And that's exactly what we're going to do for our serving. So I'm going to define a serving function here, and I'm basically going to copy and paste that code and format it. So that's returning our serving. And now I can start a serving service within our app, right? By doing, look, I want to run ANX serving. The serving is exactly what is returned by this function, okay? And what else I'm going to do here is that we need to give it a name. I'm going to call it my serving, okay? We can give it any name. The name doesn't really matter. I'm going to call it my serving, and this is it. The default batch timeout is 100 milliseconds. That's good for us. We can increase the batch size. We can say the batch size is 10. And we are also going to compile it by default, okay? Compile it by default, that means every time our app starts, it's going to compile the neural network. This one is quite fast to compile, but it's alright. But so it's alright to do that every time. But you may want to do, look, I'm only going to compile it beforehand in prod, for example. And then in development, you don't have to pay this price up front of compilation. But anyway, like all the knobs that you need, they are here, right? We're going to stick with the defaults just increasing the batch size. And that's it. And now that we have myserve running, okay, what we are going to do is that we are going to go back to our page live. We are going to say, now I'm going to use the NX serving to do a batched run on the myserving process, passing the text. And this is it. We are actually going to end up like removing code as part of this. Like the actual code is less than the stub that we wrote, right? So that's it. We're going to do a batched run. And that's all that we need, okay? This is going to work because I don't think this result is going to be just a label, but let's give it a try, all right? So let's go back here. Let's go back to our Phoenix app. Let's start something, and it crashed. If we go to the logs, it says the process is not running. And the reason why the process is not running is because we changed the services. We have to restart our app. So let's restart the app. And again, you can see it's taking a little bit of time because we are doing that compilation. But now the app's running again. I'm going to type something. It's going to crash. We're going to look at the terminal again and say, look, the reason why it's crashing is because we're trying to print something as HTML, but I have no idea how to convert this to HTML. Okay? So this is our data. This is our result. Okay? It's this. for that particular input, which it was just random thing. So you can say it's like it's others. I don't know what that is, right? So you can see this is our result. And we could show as many labels as you want. So for example, what you could say, you could do like, look, I'm going to show any label more with more than like 30% certainty. You can customize that. But in our case, for simplicity, I'm going to use pattern matching to get only the first label, right? Because it already comes in order. So we have like result predictions. That's how it looked like. We are going to pattern match on the first one. We are going to get the label. We don't care about the score. We could show the score as well if we wanted to say how confident that it is. And the label is the result. Okay, so now we go back to the app and we can have a happy face and it says joy. We can have a sad face, it's going to say sadness. We can be amazed at how well this works. So this is it, right? So we just saw how we could get the neural network, right? Very quickly, right? We changed the supervision tree to start the serving. We restarted the app, so that new service is start running. And now we can do batched predictions on it, right? And the cool thing is because we are batching, right? If we start getting more users into the application, we can customize the batch parameter, we can customize the timeout parameter in order to provide like the best user experience. And what is really cool about this is that like everything is implemented in pure Elixir, right? Like, so we have this NX serving thing that is running in Elixir with your application. You don't have to go and get your models and define a separate server only to serve them, right? You have that choice, certainly, but you don't have to. And this gives a lot of control to do things like, again, embedding into data processing pipelines, embedding into nerves embedded systems, right? And run that on the device. So all those options, they are available to Elixir developers. So that's it. This is very exciting. You can probably see how excited I am about this. The NX, Axon, and Bumblebee teams have been working on this for months, so we are really glad to release it. And we hope you're going to enjoy it. We hope that is going to unlock a new set of ideas and a new set of tools for you to experiment with and build new and exciting things. So if you want to try this out, right, you can go to the Bumblebee project. We have a examples Phoenix directory with a bunch of single file Elixir Phoenix applications that you can just go and try things out, get feedback, and you can start porting that to your actual app. Again, you can install Livebook 0.8 and use the click things like go the smart cell and start playing with that. And if you want to look a little bit more to how things work, the APIs, we have also written notebooks. So there's a lot of material for you to play with, get started and start having fun with this. So thank you so much. We really hope you enjoy it and have a good one.